Learning target number 4 for weather is I can describe the weather associated with low pressure systems and high pressure systems. Your essential vocabulary is low pressure system, high pressure system, and humidity. It's not the heat, it's the humidity. Have you ever heard someone say that on a warm, muggy day? As you'll see soon, there's a lot of truth in that statement. To understand humidity, you must first have to realize that there's water in the air all around you. But I'm not wet, you might say. That's true. Most of the air around you has water in the form of gas called water vapor. Humidity is the amount of water vapor in the air. Too much or too little humidity can be dangerous. For example, high humidity combined with hot temperatures is a combination that can be a health risk, especially for very young and the very old. Humidity plays an important role in our daily weather. Without water vapor in the air, our weather might be like the weather on Mars. Can you imagine life without clouds, rain, snow, thunder, or lightning? To fully understand humidity, you must reference a map. See that it is more humid in areas near large bodies of water. Think of the difference between Arizona and Florida. So look at the map. Drier air masses are in orange and red due to being north of Mexico or land. In Florida and north, more humid air comes in due to the Gulf of Mexico or water. If you are a regular viewer of weather broadcasts, chances are you've heard of the following from your local TV meteorologist. Plenty of sunshine in store today as high pressure is in control over the area. Or expect rain to spread into an area as low pressure system approaches. It is well established that high pressure is generally associated with nice weather, while low pressure is generally associated with cloudy, rainy, or snowy weather. But have you ever wondered why? In order to understand the types of weather conditions generally associated with high and low pressure systems, we must think vertically. The motion of air in the atmosphere above our heads plays a large part in the weather we experience here at Earth's surface. Basically, air cools as it rises, which can cause water vapor in the air to condense into liquid water droplets, sometimes forming clouds and precipitation. On the other hand, sinking air is associated with warming and drying conditions. So the first important point to keep in mind is rising air equals moistening, and sinking air equals drying. The airflow due to the Earth's rotation and friction is directed slightly inward toward the low pressure center and slightly outward away from the high pressure center. The slightly inward moving air in low pressure causes air to converge, and since it can't move downward due to the surface, the air is forced upward, leading to condensation and precipitation as discussed earlier. The opposite occurs with high pressure, as air is moving from the high pressure center at the surface or diverging, so as a result, air from above must sink to take its place. The surface flow is accompanied by the opposite behavior at upper levels of the atmosphere, as depicted in this scheme diagram. Now there is much more to it than just high pressure equals nice weather and low pressure equals bad weather. Otherwise, I'd be out of a job. But hopefully after reading this, you will have a better understanding of why meteorologists talk about pressure systems. We will get more detail in Learning Targets 5 and 6. So a little review. High pressure systems equal cooler and dry. Not much evaporation to form clouds above it. This causes sunny, clear skies because cool air is sinking. Now for low pressure systems, It is warm and more humid, evaporation to form clouds. This causes cloudy skies because warm air is rising.